My name is Megan, and I'm going to be teaching you about inclined planes. Inclined planes can be found everywhere in your everyday life. For example, stairs are an inclined plane. They are set at an angle and they help you get from one platform to a higher platform. My driveway is an inclined plane. You can use an inclined plane to roll a ball into the back of your car. Now we're going to measure the stairs for the application problem. The stairs are 6 feet long. The stairs are 3 feet high off the ground. Now we're going to sketch out an application problem using the measurements from the stairs we just measured. For this application problem, I will not be drawing in the actual stairs, but just a simple inclined plane. Make sure you use a straight edge to make the lines and the diagram as neat as possible. For this application problem, this is representing the landing in front of my front door, and these are the stairs. First, we're going to fill in the measurements we just got from measuring the stairs themselves. They were 3 feet high and 6 feet long. For this problem, we will be pushing a box up the stairs that will weigh 200 pounds. First, we need to find this angle right here. To do this, we use the inverse sine formula and plug in the height of the stairs over the length of the stairs, or the opposite over hypotenuse, as in SOHCAHTOA. Once we plug this into our calculator, we get that the angle is 30 degrees. Now, we're going to find the mechanical advantage. To do this, you set MA equal to the length of the inclined plane over the height. This equals 2. There are no units for mechanical advantage. Next, we need to find the force needed to push the box up the inclined plane. To do this, we need to resketch a diagram and draw in all of the forces. We find that FG is still 200, or the weight of the original box. Next, we plug in 200, the weight of the box, and 30 degrees, the degree of the angle of the inclined plane, into the polar to rectangular function on our calculator, and find that the force needed to push the box up the inclined plane is 100 newtons. Now, for the review. First, we found the angle by using the inverse sine function on the calculator. You push the trig function in your calculator and go to the inverse sine. Then you plug in 3 for the height over 6 for the length. This is how we got 30 degrees. Once we found that the degree of the angle was 30, we then found the mechanical advantage. Mechanical advantage is length of the inclined plane over the height of the inclined plane. We found that the mechanical advantage is 2. Remember, there are no units for mechanical advantage. Next, we need to find the force needed to push the box up the inclined plane. To do this, you push the little book icon on your calculator and select the polar to rectangular for the y coordinate. Next, we plug in 200 for the weight of the box, comma 30 for the degree of the angle. This is how we got 100 newtons.
I'm John Lucas, and I approve this message.